What is the evidence that they've discovered on Mars?
What they found was organic chemistry. We have to at least consider the possibility that these are artificial structures.
There have always been theories about life that might have existed on Mars, but never any compelling evidence. That was until now. This ancient megastructure was just found. Could this be the work of a long-lost civilization? 1. The Pole Crater. Pole Crater is a massive crater on Mars, stretching about 68 miles across. It's located in the northern lowlands of Mars, in an area called Cris Planitia. Scientists think this crater formed about 3.4 billion years ago, when a large asteroid, somewhere between 3 and 9 kilometers wide, smashed into what may have been a Martian ocean. This impact likely caused a huge megatsunami, with waves that could have reached heights of 820 feet and traveled as far as 932 miles. What makes Pole Crater super interesting is that it formed on top of ancient flood channels. This means the crater came after Mars had its initial ocean, but before all the water disappeared. Surrounding the crater are deposits believed to be leftovers from the mega tsunami, which helps scientists piece together Mars's watery past and consider the possibility of life. Interestingly, NASA's Viking 1 lander, which touched down on Mars in 1976, might have landed on sediments from this ancient tsunami, adding more depth to our understanding of Mars's watery history. 2. The Olympus Mons. Olympus Mons is the biggest volcano in our solar system and is located on Mars, in the Tharsis region. It's absolutely massive, standing about 13.6 miles tall, nearly 3 times higher than Mount Everest. Its base spans around 370 miles, making it about the size of France or Arizona. Olympus Mons is a shield volcano, which means it has a wide, gentle slope due to flowing lava with low viscosity. The slope is only about 5%, so the climb up would be gradual. At the top, there's a group of 6 calderas, craters, that formed when the ground collapsed after volcanic eruptions. These calderas cover about 7 miles and are 2 miles deep. This volcano likely formed over billions of years, with lava continuously erupting from the same spot because Mars doesn't have shifting tectonic plates. Some parts of it are thought to be as young as 115 million years, and the last eruptions may have happened just 25 million years ago. 3. Polar ice caps. The polar ice caps on Mars tell us a lot about the planet's climate and geology. Mars has 2 permanent ice caps, one at the North Pole and one at the south, made up of water ice and dry ice. These ice caps grow and shrink with the Martian seasons, depending on temperature and sunlight. The northern ice cap is mostly water ice, with a thin layer of dry ice in the winter. It can grow by 1.5 to 2 meters each winter and shrinks again in the summer. It's about 620 miles wide during the summer and holds enough ice to cover Mars with a 2-kilometer thick layer. The southern ice cap is smaller, at around 217 miles in diameter. It's mostly dry ice with some water ice underneath. The dry ice layer is about 8 meters thick, while the water ice can be up to 3 kilometers deep. These ice caps aren't just cool, they also hold climate records, like tree rings, that help scientists study Mars' past climate. Plus, they might be key for future Mars exploration, providing water for potential human missions. 4. A Buddha statue. The idea of there being a Buddha statue on Mars comes from a photo taken by NASA's Curiosity rover, where some UFO enthusiasts claim they spotted a rock formation that looks like a Buddha figure. They say it has a face, a rounded belly, and other human-like features, sparking online speculation that ancient civilizations might have once lived on Mars. If this were true, it would completely change what we know about the universe. Maybe Mars wasn't always the cold, barren planet it is now. Perhaps intelligent life once flourished there, leaving behind statues and other signs of their existence. People like Scott C. Waring believe this statue could be proof of an advanced culture that existed long ago on Mars, and some even suggest global organizations should investigate. While scientists haven't confirmed any such thing, explaining it as just a natural rock formation, It's fun to think about the possibility. What if Mars held secrets of past civilizations waiting to be discovered? 5. Water. A long time ago, around 3.8 billion years ago, it seems like Mars might have had huge oceans covering about a third of its surface. Scientists see signs of ancient rivers, deltas, and lake beds that show water once flowed there. The Curiosity rover found rocks in Gale crater that formed in water, hinting that Mars used to be pretty wet. Plus, the Mars Express orbiter picked up hydrated minerals, which have water molecules stuck in them. Today, Mars still has a lot of water ice, especially at the poles and underground. The Mars Odyssey orbiter has mapped out huge ice deposits beneath the surface. New data from the InSight lander suggests there are even large amounts of liquid water trapped deep inside the Martian crust, about 6 to 12 miles down. There's no stable liquid water on the surface now, but there might be brief periods when salty water forms under certain conditions. This deep water could potentially support tiny life form. 6. Mosaic of local magnetic fields.
I wonder what kind of a world we're opening the door on.
You'd wonder even more if you saw the pictures of Mars that we saw last night.
Mars doesn't have a global magnetic field like Earth does, but there are some cool magnetic features on the red planet. Satellites like MAVEN and the Mars Global Surveyor have shown that Mars's surface is covered in patches of magnetic fields. These fields come from volcanic rocks that still hold on to a bit of Mars' old magnetic vibe. On Earth, our magnetic shield is created by the churning metal in the planet's core. As iron and nickel move around, they generate an electric current that powers our planet's magnetic field. Mars, being smaller, cooled down faster than Earth, so its magnetic activity died out long ago. But as the surface solidified, the rocks captured a snapshot of that old magnetic field, and that's why we see these scattered magnetic fields today. These magnetic patches lead to some pretty spectacular auroras on Mars. Unlike Earth, where auroras are usually seen at the poles, Martian auroras can show up close to the equator because there's no big global magnetic field to keep them in check. 7. Ancient lake evidence. The Perseverance rover landed in Jezero crater, which scientists think used to be a huge lake with a river delta. This crater was created by an asteroid impact almost 4 billion years ago, and then it filled up with water, making it a potentially habitable place. Radar data from the rover shows layers of sediment at the bottom of the crater, similar to what we see in lakes here on Earth. The rover also explored a delta within the crater, where it found sediment layers deposited by water flowing into the lake. These layers look a lot like the ones we see in terrestrial lakes. The data even showed changes in sediment, suggesting that water levels in the lake went up and down over time. The sediments in Jezero crater have minerals like clay and carbonate, which usually form in water and might hold clues about past life. Some samples also contain phosphate, which is crucial for life as we know it. 8. Rock formation ages. Figuring out how old Martian rocks are is super important for piecing together Mars's geological past and checking if it might have had life. The Curiosity and Perseverance rovers have been doing some amazing work in this area. Curiosity uses a technique called potassium-argon dating, which checks the ratio of radioactive potassium to argon gas to figure out how old rocks are. For instance, a rock from Gale crater turned out to be between 3.86 and 4.56 billion years old. Another method, argon-argon dating, is used on Martian meteorites found on Earth, showing that some volcanic rocks are between 161 and 540 million years old, hinting that Mars might still have some volcanic activity. Mars has different geological periods, with the Noachian being the oldest, around 4.1 to 3.7 billion years old, showing lots of water activity. The Hesperian period, from about 3.7 to 2.9 billion years ago, was all about volcanic action and lava plains. The Amazonian period, starting around 3 billion years ago, has fewer impacts and ongoing geological changes. 9. Jarrow Site. Discovered by the Opportunity rover in 2004 at a site called Meridiani Planum, Jarrow Site showed up thanks to a special tool that measures iron in rocks and soil. This spot had layered rocks, hinting that water once played a role there. Jarosite forms in places where water is acidic and oxidizing, like Earth's acid mine drainage areas. So finding it on Mars suggests the planet had similar conditions a long time ago. This might have happened because of weathering of iron-rich rocks by acidic waters or through evaporative basins where water dried up, leaving behind jarosite. There's also a thought that it might come from volcanic activity or even weathering of mineral dust in icy areas. The mineral tells us Mars had liquid water and acidic conditions in its past, which is important for figuring out how habitable the planet might have been. Scientists are still digging into how jarosite fits into Mars's history, using both Earth analogs and ongoing missions like Perseverance to get the full picture. 10. Organic compounds. The hunt for organic compounds on Mars is a big deal because these molecules, which include carbon and other elements like hydrogen and nitrogen, might give us clues about past life. The Perseverance rover, which landed in Jezero crater in early 2021, has been busy detecting these compounds using its Sherlock tool. This tool shines ultraviolet light to spot organic molecules by their unique glow and scatter patterns. So far, Perseverance has found various organic molecules, including some simple carbon chains and aromatic compounds, which suggest Mars had a mix of organic materials in its past. Jezero crater is a great spot for this search because it was once a lake and it has minerals like clays and carbonates that could help preserve these organic materials. These compounds might have formed either on Mars through chemical reactions or arrived from space via meteorites or dust. Finding these organic molecules is exciting because they're the building blocks of life, but it's important to remember that they can also come from non-living processes. Earlier missions like Curiosity also found organic compounds in rocks, and Martian meteorites have shown these molecules as well. 11. Methane variability.
In Spacewatch, NASA scientists say its Curiosity rover made a discovery that could indicate signs of life on Mars.
The hunt for methane on Mars has been quite a journey for scientists because methane can hint at possible life. Methane, a simple organic molecule, can come from both living things and geological processes. The first hint of methane on Mars came in 2004 from the Mars Express orbiter, which found about 10 parts per billion. Since then, methane levels have varied a lot, with some readings hitting as high as 45 parts per billion. Curiosity rover, which has been roving around Gale crater, also picked up on methane. It found spikes in 2014, where methane shot up to around 7 parts per billion, but then dropped back down. Curiosity's data showed that methane seems to follow a seasonal pattern, peaking in the warmer months and dropping in winter. It also looks like methane levels can vary from day to night, with higher levels at night and lower during the day, possibly because methane gathers near the surface at night and mixes away during the day. Scientists don't actually know where all this methane comes from. It might be produced by microbial life or geological processes like serpentinization, where water interacts with rocks. There's also a theory that methane might come from clathrates, which are ice-like structures that trap gas and might release methane when temperatures rise. 12. Mud cracks. When NASA's Curiosity rover spotted mud cracks on Mars in 2021, it was a big deal for understanding the planet's past. These cracks were found in Gale crater in an area called Pontour, which sits between clay-rich and sulfate-rich layers. This spot shows how Mars changed from wet to dry over time. Mud cracks form when wet mud dries out and shrinks, creating fractures. Initially, these cracks look like T-shaped junctions, but over time, they evolve into Y-shaped patterns and then into hexagons. The hexagonal patterns Curiosity saw are similar to those on Earth, like in Death Valley, where similar dry conditions occur. The salty crust around these cracks helped preserve them for billions of years, which is awesome for scientists studying them. These cracks show that ancient Mars had regular wet-dry cycles, suggesting a climate similar to early Earth. This means Mars might have had conditions that supported life. 13. Fossilized remnants. While driving through Neretva Vallis in Jezero Crater, Perseverance came across a rock called Cheyava Falls. This rock is pretty interesting because it has white calcium sulfate veins running through it, which suggests water once flowed there. Even cooler, there's a reddish area between these veins packed with organic compounds, picked up by Perseverance's Sherlock instrument. Plus, there are tiny off-white splotches on the rock that look like leopard spots. Scans of these spots with the PXL instrument reveal chemicals that could have been energy sources for ancient microbes. If these features really are from ancient life, it could be the first proof of life beyond Earth. Perseverance has collected a core sample of this rock, which will eventually be sent back to Earth as part of the Mars Sample Return Program, a joint project between NASA and ESA planned for the 2030s. 14. Subsurface habitability. While the surface of Mars is pretty harsh with extreme temperatures and intense radiation, the underground could offer a more welcoming environment for microbes. First off, the Martian surface is bombarded with cosmic and solar radiation, which isn't friendly to life. However, the subsurface provides a kind of shield from this radiation, making it a safer place for any potential life forms. Plus, the underground environment is generally more stable, with less temperature and pressure fluctuation, which is ideal for life. Recent studies hint that liquid water could be lurking underground, especially a few kilometers down, where conditions might be just right. This groundwater could be a crucial resource for microbes. There are also salty brines that form occasionally, offering another potential habitat for extremophiles. On Earth, life in deep underground environments relies on chemical reactions for energy. Similar processes could be happening on Mars, with minerals in the rocks, possibly providing the necessary nutrients. Plus, geothermal gradients could make the deeper parts of Mars warm enough to support life. 15. Will we ever establish Mars as a colony? The idea of living on Mars has been talked about quite a lot, but turning it into reality is a whole different ballgame. Right now, we're looking at some serious hurdles. Mars is not exactly the most welcoming place. It's cold, with little air to breathe and tons of radiation. We'd need to build habitats that can keep us safe and provide everything we need to survive. Plus, getting all the stuff and people there is a huge challenge on its own. Rockets like SpaceX's Starship are making big strides, but they still need to be fully up to the task. But on the flip side, technology only seems to be on the rise, and with how things are going right now, no one knows what's possible. 16. Why colonizing Mars is so complex. Mars colonization is one of the most ambitious projects ever. The goal is to set up a human settlement on Mars, which is a massive challenge. Mars is about 150 million miles away from Earth, and it's not a friendly place. It's cold, dry, and has very little breathable air. Plus, it's bombarded with radiation, so any humans living there need protection from that. Creating a livable colony on Mars is basically trying to set up a new town in a harsh desert on another planet. You have to figure out how to provide everything people need to survive: water, food, air, and shelter. It's a big job, but with the technology and teamwork from these organizations, we're moving closer to making a Mars colony happen. 17. The scale of the Mars mission. The scale of the Mars mission is absolutely massive. We're talking about something on a level that's hard to even grasp. It's not just about sending a few people to Mars and calling it a day. It's more like trying to build a whole new world from scratch. Mars is about 150 million miles away, so getting there isn't a quick trip. It takes a lot of time, effort, and resources to make it happen. The mission involves more than just sending rockets. You need to figure out how to transport tons of supplies, from food and water to building materials and equipment. Plus, the rockets themselves have to be super powerful to carry all this stuff through space. On top of that, you need to create habitats that can keep people alive in Mars's harsh environment. That means dealing with extreme temperatures, radiation, and a lack of breathable air. So, this mission is huge in every sense of the word, requiring massive planning and coordination to pull off. 18. Opportunity to reach Mars. Reaching Mars is a once-in-a-lifetime chance that we've never had before. Humanity has always dreamed about exploring other planets, and now we've got the technology to actually make it happen. But this opportunity isn't going to stick around forever. The window to reach Mars is open right now because of our current tech and advancements in space travel, but it might not stay open forever. We've developed some amazing rockets and spacecraft, thanks to companies like SpaceX and organizations like NASA. SpaceX's Starship is a game changer, designed to carry a huge amount of cargo and people to Mars. This kind of tech makes the idea of colonizing Mars more realistic than ever. But it's not just about getting there. It's about making sure we have everything we need to survive and thrive once we arrive. 19. Goals for Mars. The goals for Mars are all about turning this distant planet into a place where humans can live and thrive. The big dream is to set up a permanent human settlement. This means more than just sending a few astronauts on a mission. It's about creating a self-sufficient colony. The plan is to build habitats that can protect people from Mars's harsh conditions, like its extreme cold, low air pressure, and high radiation. Another goal is to develop technologies that can help us survive and make life on Mars as Earth-like as possible. This includes figuring out how to produce food and water on Mars, generating energy, and recycling waste. There's also a focus on making Mars exploration a regular thing. The idea is to establish a routine of sending missions back and forth, gradually building up infrastructure and learning more about the planet. 20. Transporting supplies to Mars. Transporting supplies to Mars is one of the biggest hurdles in making a Mars colony work. It's not just about sending a few packages. We're talking about moving a whole lot of gear and resources across an enormous distance. Mars is about 150 million miles away, so it takes a lot of planning and tech to get everything there safely. There's the challenge of getting all the supplies into space. Rockets need to be incredibly powerful to carry everything from food and water to construction materials and scientific equipment. Thankfully, SpaceX's Starship is designed for this kind of heavy lifting. It's supposed to handle big payloads and make regular trips to Mars, which is a huge deal for keeping the colony supplied. Once the supplies arrive, they need to be managed and used efficiently. Mars has no atmosphere to speak of, so everything has to be carefully stored and protected. Creating a reliable system for transporting and using resources is crucial. This includes figuring out how to handle waste, generate power, and make sure there's enough food and water for everyone. 21. How NASA and SpaceX work together. NASA and SpaceX are basically the dream team, at least when it comes to getting to Mars. SpaceX's Starship is a game changer for deep space missions. It's built to carry tons of cargo and people to Mars, which means NASA can lean on this tech instead of building their own spacecraft from scratch. Plus, SpaceX's reusable rockets are a huge win for cutting costs. They've already made space travel cheaper and more frequent, and this could be a big boost for Mars missions. NASA is all about using their space knowledge and research to improve mission planning. By working with SpaceX, they can mix NASA's experience with SpaceX's innovative tech. This means they can plan and execute missions more effectively together. Also, SpaceX's fast development and testing process can speed up new technologies for Mars. They're looking into using Mars resources to make fuel and other essentials, which is something NASA is keen on too. With more frequent missions, we'll get more data and insights about Mars quickly. 22. Testing Mars habitats. Testing Mars habitats is mainly figuring out how to make living on Mars actually work before we send people there for real. Since Mars is so different from Earth, cold, dry, and with hardly any breathable air, we need to make sure our habitats can handle these extreme conditions. NASA and other teams are working on creating mock habitats here on Earth that simulate the Martian environment. These test habitats are designed to give us a taste of what life on Mars might be like. They include things like air, water, and food systems, and are built to handle the isolation and harsh conditions that come with being on another planet. The idea is to see how well these habitats perform and figure out any issues before the real deal. We need to test how people react to being in these environments for long periods, and how well the habitats can protect them from radiation and extreme temperatures. These tests help us tweak and improve the designs, so when we finally build real habitats on Mars, they're ready to provide a safe and livable space for future astronauts. What other things are there on Mars? Do you think we'll ever make it there on our own?